Just like number 8, we're going to start by writing an equation that models the graph we're given. And so to find this graph, by the way, I look at our Teams page. Unfortunately, when I copied off the papers, the copier in this building does not properly illustrate the graphs that are on my Word document. So y equals a times b dx. The key is when you have graphs, it's not x minus 1 unless we're shifting it left or right. Okay, so here we go. I'm going to start with 1. So here's my output. 1.5 equals a times b to the first. Now I'm going to isolate the a by dividing by b. B is happy. B is happy, so I have 1.5 over b to the first. Okay, b is happy. I'm not going to move it up to the top unless it's at a negative exponent. Doing the same thing over here. So I have y equals a times b dx. My output is 4.5. Okay, this is what a is equivalent to. And my input is 2. Now, when I reduce these two, this is like having two b's on top of one on the bottom. When you reduce it, you're left with just one b on top. So I'm going to start by isolating the b by dividing by 1.5. So I have 4.5 divided by 1.5, and that's going to give us our b value. 4.5 divided by 1.5, and I get an answer of 3. So b to the first, or b, equals 3. Then I have to come back up here and go 1.5 divided by 3 is equivalent to 0.5, or 1/2. It doesn't matter if you write it as 1/2 or 0.5. So my final equation that models this graph is y equals, your a is 0.5 or 1/2, the b is 3, remember it's not x minus 1, this would be my answer. Now, is this growth or decay? Well, from left to right, it is going up, so it is growth. What's another way to be able to tell that? This common ratio is greater than 1. Just like our last graph, we can see that we do have a horizontal asymptote at y equals 0. And then let's go with the end behavior. So as I go to the far left, what's happening? Way over here, it's getting closer and closer to the x-axis. As I go to the far right, it is headed up towards positive infinity.